The transformer is a device that converts alternating or pulsating electric current with a higher voltage into alternating or pulsating energy with lower voltage or tension without substantially changing the power. The transformer requires the input current to change state constantly, either by being alternating current, which changes its polarity, or by the use of pulsating current generated by electronic control by turning a circuit on and off, so that the magnetic field of that current changes rapidly, and thus an output current can be induced with a different voltage. The transformer consists of two coils of conductive material wound on a closed core of ferromagnetic material, but electrically insulated from each other. The only connection between the coils is the common magnetic flux, which is established in the core, generally made of iron, or stacked sheets of electrical steel to optimize the magnetic flux. The coils are called primary and secondary, depending on whether they correspond to the input or output of the system in question, respectively. Some transformers also have a tertiary winding of lower voltage than the secondary. On an electronic board, the transformer allows the voltage to be reduced in an electrical circuit while maintaining power. In an ideal transformer, without losses, the power input is equal to the power output, although real machines have a small percentage of losses, depending on their design and size, among other factors. In air conditioning and refrigerator electronic boards, there are basically two types of transformers. 1. Conventional transformers, located at the entrance of the electronic board, usually located independently of the electronic board, and are responsible for receiving the voltage from the external electrical network of the alternating type at 50 or 60 Hz, and frequently transforming it from 12 or 24 volts AC. Subsequently, this voltage will be rectified by a bridge of diodes, stabilized by capacitors, and regulated by the voltage regulator to supply stable direct current to the electronic board. 2. Switch mode transformers, also known as switching transformers, or high-frequency transformers. Unlike conventional transformers, switch mode transformers do not directly receive current from the external electrical network, but receive it from a special current generated by the electronic board, which operates at high frequency, usually in the kilohertz or megahertz range. These transformers allow efficient conversion of voltage and current in switch mode power supplies. They usually work with pulsating direct current. These transformers are more efficient than traditional linear transformers due to the high frequencies, which allows them to be smaller and lighter. Now let's see the steps to diagnose a transformer. 1. Check for visible damage, such as deformations or burn marks. If the transformer is bulging or shows signs of overheating, consider replacing it. 2. Turn off the power to the circuit and disconnect the transformer from the electronic board. 3. With the multimeter in the resistance function, measure the resistance of the primary and secondary coils. It should be low and never mark infinite. 4. Power up the electronic board or transformer. 5. Use a multimeter in the alternating voltage function to measure the voltages at the primary and secondary. 6. Compare the values with the transformer specifications.